प्लीज. ठीक.
The next topic in Unit 2 is scaling up and scaling out. These two terms we have used for the first time, but we are familiar with the two terms, that is horizontal scaling and vertical scaling. So horizontal scaling is the new name for scaling out, and vertical scaling is the another name for scaling up. So we have discussed these terms but with a different name. What is horizontal scaling and what is vertical scaling? It will be revised in this scaling out and scaling up. What is scaling up? Scaling up and scaling out are both approaches to increase storage capacity. To decide which approach to take, consider short-term and long-term requirement. So for long-term requirement, scaling out or horizontal scaling is applicable, and for short-term requirement, scaling up or vertical scaling is applicable. Both approaches increase capacity of an existing storage infrastructure. To decide between scaling up versus scaling out for storage, consider factors such as data growth expectations, budget, criticality of the system and existing hardware. Generally, organization will scale up or vertically scale when they face performance issues and need a short-term fix. They will scale out when flexibility is important. In a scale-up approach, organization add to existing infrastructure such as with more disk or drives. If it is important to retain the same device rather than splitting up critical applications and data across multiple storage devices, use a scale-up approach to scale storage. This is also known as vertical scaling. This is the diagram. Initial storage divide, the additional storage is added on the same disk. So the following are the some advantage of scale-up approach. Since the underlying hardware is a single device, storage management is simplified. There are low costs associated with licensing and additional equipment such as networking. Organization do not need to change the system architecture. The second thing is scale out or horizontal scaling. For long-term upgrade, management may determine that they need more storage and the unique requirement will need specialized storage such as solid state drives and additional hard disk drive. In practice, it may be necessary to add more equipment racks close to the original storage equipment. In such a situation, it makes more sense to boost storage by configuring a variety of devices that support those requirements. This is referred to as scaling out from the initial storage, or it is also known as horizontal scaling. This is the diagram, initial storage. So we are adding a new machine or new node for additional storage devices like this. The advantage of scale out storage include the following. It benefits from improvement in storage monitoring as fault identification and tolerance is easily applicable. Organization can implement newer storage and server technologies. Storage sources can be located virtually anywhere. A scale-out approach is good for long-term requirement. Then map-reduce framework and basics or map-reduce architecture. So in the previous slide we studied about how the analyzing data with map-reduce is performed. Now what is map-reduce architecture? Map-reduce is a programming model used for efficient processing in parallel over large data set in a distributed manner. The data is first split and then combined to produce the final result. The libraries for map-reduce written in so many programming languages very different. The purpose of map-reduce is to map each of the job and reduce the equivalent for providing less overhead over the cluster network and to reduce the processing power. So this is the map-reduce architecture. Client assigns the job to the map-reduce framework. Then the job is assigned to the Hadoop MapReduce master. What Hadoop MapReduce master does, it divides the job into the smaller job parts, and that job parts will be assigned to the mapper function, then reducer function, then output data This is the this 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 framework we have familiar with because it is the diagram of mapper and reducer function. But if we talk about the whole MapReduce architecture, in it client is also associated with it. Then client assign the job to the Hadoop framework. Then Hadoop MapReduce master changes it to the small parts, and then the same processing is done. And from where input data is fetched, it is fetched from the HDFS. Then the data set is fetched from the HDFS, and what work should be done, it is assigned by the client job. For example, what is the, if we talk about the word count problem, so the job is the work of counting the number of words in a text or in a text or in a paragraph. The client assigns this job, and the data set is the text file on which that work is to be done. So it is fetched by the HDFS. Component of MapReduce architecture, then we will define what is client, who is client, what is job, Hadoop MapReduce master, what it does, job parts. The client is the person, or it is one who brings the job to the MapReduce for processing. What is job? The MapReduce job is the actual work that the client wanted to do, which is comprised of so many smaller tasks. Hadoop MapReduce master, what it does, it works is to divide the particular job into subsequent job parts. Job parts is the task or sub-job that are obtained after dividing the main job. So the result of all job parts combined to produce the final output. Input data is the data that is fed to the MapReduce for processing. Then output data is the final result after processing. In MapReduce we have a client. The client will submit the job to a particular size to the Hadoop MapReduce master. Now the Hadoop MapReduce master will divide, and it will, the output of the map key value is then fed to the reducer, and the final output is stored in the HDFS. So map and reduce we have studied earlier also in the, then two new terms comes into the picture, that is in the MapReduce framework, job tracker and task tracker. What is job tracker? The work of job tracker is to manage all the resources and all the job across the cluster, and also to schedule each map on the task tracker running on the same data node, since there can be 100 of data node available in the cluster. So job tracker runs on the master node or at the name node, and task tracker works on the slave node or on the data node. Task tracker can be considered as the actual slaves that are working on the instruction given by the job tracker, or it is a master node. This task tracker is deployed in each of the nodes available in the cluster that execute the map and instructed by the job tracker. There is also one important component of MapReduce architecture known as job history server. The job history server is a daemon process that saves and stores historical information about the task or application, like the logs which are generated during or after the job execution are stored in the job history server.